you are expecting some load or you are attaching some load here. Whose load impedance is ZL. And characteristic impedance of this transmission line is around Z0. Okay. So that is the characteristic impedance of the entire transmission line. So randomly, if I want to take the, if I want to consider entire line, what will the impedance mean? That will be Z0. So if I am feeding some power in the form of voltage here, it will go to ZL, and if this ZL is matched to Z0 actually, there will not be any reflecting power from the ZL. Why? Because entire power will be absorbed by the ZL. But if there is a mismatch between characteristic impedance and load impedance, generally some power will be transferred from transmission line to load, and remaining power will be reflected back to transmission. Okay. That how much power it was reflected back actually is called, it will be measured by reflection coefficient. It will be indicated with some it is also sometimes it may called as a tau or gamma order. So it will be like this. Okay. That means if I calculate that gamma or tau, that will give you how much of power is transmitting back from the load. If that is 0, reflection coefficient is 0 means entire power was transferred from source to load. So it is a completely matched load. Otherwise there will be power from load to source. That is the reflected power. For that I am starting. Is there any doubt over that one? We have started last class voltage at the starting end, at any point of time, at any point of length, V of x equal to forward voltage of e power minus gamma x plus reverse voltage of e power plus gamma x. It is minus, it should be plus. And current will be forward current into e power minus gamma x plus reverse current into e power minus gamma x. So it is a mixture of both forward wave and reflectors. Now we have an equation that change in voltage with respect to distance is negative of r plus j omega l into I. Why? Because I am taking negative means after that r comma l, it will be downside. It will decrease, not increase. If I consider voltage, and if you consider voltage here, which one is higher? So from here to here, distance is increasing, but voltage is decreasing. That's why I am taking. So, but actually, what is dV by dx? You have to differentiate with x. Here, x means distance. So, if I differentiate like this, then it will be minus gamma e power Vf into e power minus gamma x plus Vr into gamma e power gamma x. We have discussed it in the last class. Am I? So if you restructure that one, dV by dx will be gamma times of minus Vf into e power minus gamma x plus Vr into e power. Then it should be minus of r plus j omega into I. Why? Because can I dV by dx equal to minus r plus j omega? Then I should be with minus Vf into r divides with r minus of r plus j omega. Here also it should be. Then if I restructure the same, gamma by r plus j omega, this is equal to actually characteristic impedance. In the last class we have discussed. So gamma by r plus j omega is equal to 1 by z, sorry, 1 by current. So that's why I am taking z. If you take gamma by r plus j omega, what you have to write here? Root of r plus j omega L into g plus j omega. If you cancel out this one, it will become 1 by z naught, 1 by characteristic. Can I take z naught outside? Then it should be V plus Vf. Why? Because I am taking this minus 2. Vf into e power minus gamma x minus Vr into e power plus gamma x. Now I am taking from voltage equation, I am taking Vf into e power minus gamma x outside in first equation. Then there will be one and VF you are taking, then it should be VR by VF. Here it should be e power plus gamma minus gamma x. Minus gamma x. If you go above, it will be plus. Here also it should be plus. I'm sorry. Okay. Yes. I of x equal to Vf into e power minus gamma x by Z naught. Why? Because I am taking current equation. Should be 1 minus Vr by Vf into e power plus 2 gamma. If I consider from load end means if I consider here, for this it is x equal to 0 or not? At x equal to 0, what is voltage by current? ZL only. See, what is this equation actually? This is ratio of voltage to current at any distance x. At any distance x. From source end, if I take x equal to 0, you will have load at x equal to L, correct? From load end, if I take x equal to 0, then it should be load or not? So at load side, if I consider x equal to 0, then what will be the ratio of V of x by I of x? ZL only. At x equal from load end I am taking. From load end, if I take here x equal to 0 and here also x equal to 0, then V of 0, V of 0. At this end, what will be the ratio of V of 0 by I of 0? ZL only. Why? Because current is always ratio of voltage to current. Should be ZL. And here if you consider, if you take the ratio of VF cancel out minus gamma x, then it will become Z naught. Is it correct? Into 1 plus VR by VF. Just now I told you what will be the reflected power or reflected voltage. I mean reflection quotient means what is the amount of voltage you are getting back and what is the voltage you are giving. So reverse voltage to forward voltage. Okay. So how much fraction of forward voltage is getting back? That is called reflection quotient. Can I take VR by VFS? Like this one. Sorry. Correct. So 1 plus gamma tau into e power 2x plus 2 gamma x divides with 1 minus gamma into e power plus 2. Then if I substitute x equal to 0, then here it should be V of 0 by of 0 equal to ZL. So ZL equal to here Z naught. If I take x equal to 0, e power 0, 1. So then it should be 1 plus tau by 1 minus 1 plus tau by 1 minus tau. That is ZL by Z naught equal to 1 plus tau by 1 minus tau. Then tau will be, you can calculate the same. Yes. I told you. So if it is a matched load, generally there will be no reflection voltage or reflective power. In case if ZL is greater than Z naught or if ZL is less than Z naught, there will be reflective power. So if it is greater than, it will behave as some inductor. If it is less than, it will behave as a capacitor. That will depend upon the ZL and Z naught values. Okay. But if ZL is not equal to Z naught, definitely you can expect some power from the load end. That is called actually reflection coefficient. It is very, very important. So that means whenever you are designing some transmission line, it should be properly designed that load and your transmission line should have same impedance. Then only power transmission will be maximum from source to load. It should be taken care of. So ZL minus Z naught by ZL plus Z. Very, very important. So why? Because here itself. Okay.